friends, welcome to Best Tutor. This is Rama Vishwanathan. In today's video, we are going to learn about factorization of algebraic expressions. We have learned the basics of algebraic expressions. We have learned how to use the operations on algebraic expressions, and then we have learned expansions. We have gone through the proof of the expansions also. Now we are going to do factorization. What do you mean by factorization? Factorization. If I have the number 12 and I have to factorize it, there is a procedure called as prime factorization. So 12 can be written as 2 into 2 into 3. This is the procedure of factorizing the given number. Now if at all we have an algebraic term over there or an expression over there, how do we factorize is the question. We have different procedures for factorization. First one is taking out the common factor. Taking out the common factor. How is factorization done by this procedure? So depending upon the question, we have to choose a procedure, right? 2x square plus 8xy plus 12y square. For example, this is a question. 2x square plus 8xy plus 12y square is a trinomial. I need to factorize it. First thing is I am going to check if there is any common factor. I am going to slightly modify the question. So what is the common factor in all the three terms is the first question. Directly by looking at the question we can make out, but that needs lot of practice. So if we don't have that practice, what are we supposed to do? I will consider each and every term and factorize those. It can be written as 2 into x into x. This can be written as 2 into 2 into 2 into x into y. 2 into 2 into 3 into x into y into y. So we have clearly written the factors of all the three terms of the given expression. Now I am going to check if there is any common factor. We observe that 2 is a common factor as well as x is a common factor. Do we find any other common factors? Y is common only to the second and third term, so we can't use it. 2 is common to second and third term, it cannot be applicable. So the HCF, highest common factor of all the three terms is 2x. So if I want to take out some common factor from all the given three terms, it's going to be 2x. So I can write 2x square plus 8xy plus 12xy square as 2x into 2x square by 2x, 8xy by 2x, this is one procedure, 12xy square by 2x, which is going to be 2x into x plus 4y plus 6y square. This is one procedure. We have taken out 2x and divided each and every term of the given expression by 2x. 2x is the HCF of all the three terms. This is one procedure. Or else directly I can write down it as, I would like to take out 2x common. So if I remove 2x from the first term, what is left over? Only x is left over. In the second term, 2 into 2, 4 into y, 4y is left over. And in the third term, 2 3s are 6 into y into y. So 6y square is left over. Excluding the HCF, whatever are the factors which are left over, I am going to combine them or multiply them and write it over there. So this is the procedure of factorizing the given expression using taking out the common factor. Because there exists a common factor, this procedure will help us. If at all we have 9y square, then there do not exist any common factor. So this procedure will not work out. So depending upon the question, we need to choose the procedure. I repeat the steps in the procedure of taking out a common factor. The given expression, we are going to consider the terms individually. We will factorize all the terms and then find out what are common factors for all the given terms. Then accordingly, we are going to choose the other factors, right? Now next one. Grouping or rearranging. I hope the first procedure is clear. Now grouping or rearranging, let me choose a question. 8 minus 4a minus 2a cube plus a to the power of 4. In this question, do I have any common factor in all the 4 terms? 8, 4a, 2a cube, a power 4. In the first 3 terms, they have a common factor 2. Last 3 terms have a common factor a. Overall, all the 4 terms do not have any common factor. So the first procedure is not applicable over there. So now we have to group or rearrange. What are we going to do? I will group these two and I will group these two. So by grouping, so in the first 2 terms, what is the common element? Here we have 4 as a common term. So I will get 2 minus a. Okay. In this first binomial, 4 is a common factor, and check whether we have done it properly or not. 4 2s are 8. 4 into minus a is minus 4a. Now in these two, what is the common factor? A cube, a power 4. So a cube is common. Let me take out minus a cube common. If we take out minus a cube common, the first term is minus 2a cube. Minus a cube is taken out common, so 2 is left over. In the second term, plus a4 is the next term of this binomial, out of which minus a cube is taken out common. What are we supposed to write here? If we have a confusion, in the rough column, we will divide a to the power of 4 by minus a cube, which is going to be minus a. Now, we have grouped them, we have got common factors, but we didn't factorize the whole expression as such. We have divided the entire expression into 2 groups, and group wise we have factorized. But observe carefully that there is something common in these 2 groups. 2 minus a is common. So, if 2 minus a is taken out common, in this first group, if 2 minus a is removed, 4 will be left over. In the second group, 2 minus a is removed, then minus a cube will be left over. Therefore, 8 minus 4a minus 2a cube plus a to the power of 4 is equal to 2 minus a into 4 minus a cube. This is the procedure of factorization by grouping or rearrangement. Let us move on to one more example. A into a plus b minus c minus bc. This is a given expression. We need to factorize it. The question doesn't look simple over here. A into a plus b minus c minus bc. First of all, let us open the brackets. A square plus ab minus ac minus bc. Okay. So we have written it in the proper way. Now let me group it or rearrange it. In the earlier example, we have grouped it. Now let us try to rearrange it. A square and AC, they have A in common. AB and BC, they have B in common. Let me rearrange the given expression as A square minus AC plus AB minus BC. We didn't change the question, we have just rearranged the terms. Now in these two, as such, overall in all the 4 terms, nothing is common. So taking out common factor does not work out here. So in this group, what is common? A is common. If A is taken out common, we are going to be having A minus C here. In these two, what is common? B is common, and again A minus C is common. Now A minus C is the expression common to both the terms. So if we take out A minus C common, we will have A in the first group plus B in the second group. So we have A into A plus B minus C minus BC as A minus C into A plus B. Let us check if our solution is correct or not. A minus C into A plus B. I am doing multiplication by vertical method. Plus B into minus C is minus BC. Plus B into A is plus AB. Plus A into minus C is minus AC. Plus A into A is A square. Why didn't I write these two terms in the below this? Because they don't have any like terms. So we have A square minus AC plus AB minus BC. A square minus AC plus AB minus BC. So the product of these two terms is A square plus AB minus AC minus BC. So factorization and then again expansion, both the procedures are done. We have checked it. So this is the procedure of factorization by taking out grouping or rearrangement. Then In the earlier videos, we have learned the formulae a plus b whole square, a minus b whole square, and similarly a plus b whole cube and a minus b whole cube. Now, if at all we have a plus b into a minus b, it's going to be a square minus b square. How do we prove it? A plus b into a minus b. Let us just do the normal multiplication. Minus b into plus b is minus b square. Minus b into a is minus ab. Plus a into plus b is plus ab. Now I can write it down because these two are like terms. Plus a into plus a is a square. Right. A square plus ab minus ab gets cancelled. So 0 minus b square. So a plus b into a minus b is a square minus b square. This is the expansion. This is the other way is going to be factorization. So how am I going to factorize an expression which is in the form of a square minus b square? I will simply write it as a plus b into a minus b. Let us do some applications of it. If we have x square minus 4, I need to factorize this given expression. Can I use taking out the common factor? There is no common factor. Can I use grouping or rearrangement? No, I cannot, because hardly there are two terms over there. How much ever arrangement or grouping I do, it remains the same. So I can't use that. So the next procedure is application of a square minus b square, or this is in the form of difference of squares of numbers. X square minus 4 is nothing but x square minus 2 whole square. 4 is 2 square. So it is in the form of a square minus b square. X minus x square minus 2 square. A square minus b square is a plus b into a minus b. So in the place of a we have x, and place of b we have 2. So x plus 2 into x minus 2. So this is a procedure of solving or factorizing the given expression which is in the form of difference of squares. Let us consider example which is a combination of the taking out common factor as well as this. For example, we have 2x square minus 18. 2x square minus 18. Firstly, we have to remember all the procedures and try one after the other. It's going to be called as a trial and error method. We have to try the first procedure. What is the first procedure? Taking out a common factor. Is there any common factor for 2x square as well as 18? Yes, 2 is a common factor. Reason is 18 is an even number, so 2 is going to be its factor. So if I take out 2 as a common factor, I will be left out with x square minus 9. Isn't it? So it's going to be 2 into x square minus 9. Did we finish the factorization? No. This can be factorizable. The reason is it can be written as x whole square minus 3 whole square. X square minus 9 can be written as x square minus 3 whole square. So it can be written as 2 into x plus 3 into x minus 3. So this is the procedure of factorizing the given expression which is in the form of difference of squares. Let us consider one example which is a combination of, let us try this example. Randomly I have chosen an example a cube plus ab into 1 minus 2a minus 2b square. Let us observe which method is applicable here and how are we going to solve it. Before we continue, we need to first simplify this. Write it in a proper way. A cube plus ab into 1 is ab plus ab minus 2a is equal to minus 2a square b minus 2b square. Right? A cube plus ab minus 2a square b minus 2b square. How am I going to do it? Is there any common factor in all the 4 terms? No. A cube, ab, 2a square b, 2b square. First 3 terms have a in common, right? And this term has, these 2 terms have 2b in common. As such we can't do. Let us try by another method. Let me try to take out a common in these 2. A square plus b. And in these 2 terms, what is common? Minus 2b, isn't it? Minus 2 minus 2b, b. So minus 2b is common. If we take out minus 2b common, we'll have a square plus b. So this is the procedure of grouping or rearrangement. Okay. Now, in this video, we have learned factorization by taking out common factor, grouping or rearrangement, and difference of square, that is a square minus b square is equal to a plus b into a minus b. Now we are competent enough to solve any problem or to factorize the given expression in either using the taking out common factor method or rearrangement method or this method, or it can be a combination of these methods, any of these three methods, isn't it? So today we have learned factorization by all these three methods. In next videos we are going to learn factorization by many more methods. Thank you.